Hi, my name is Hunter Stone. I was in charge of the load function, the file function, and changing mono versus stereo. So basically, you use UI get file to take a WAV file from your computer. This then turns it into an array, this audio read function. Then each line after that saves the data as different handles, such as like array, frequency, and then it saves it as an overall desired function or handle for playback. So the file button basically saves the different handles of the arrays into the desired arrays, which will then be used later. Then the play button simply just plays a preview of the selection selected earlier. So basically, in this mono versus stereo function, the string of whichever selection you made is saved as that variable. Then the value is also saved as that variable. And then, depending on which case you selected, basically mono or stereo, it plays the single array for the mono case, and then for the stereo case, it just plays both. So here's a demonstration of that process. So basically, you can click on load. This opens a browser where you can select your WAV file. Here's this, and then here's a preview of that. Alright, and you can stop that, and then you can select mono versus stereo playback, depending on which array you want, and then so I'll choose mono and play it.
My name is Alexis Corpus, and my part of the project was the effects and also chopping the length of the audio file. So for the effects, it's a pop-up menu, and first we retrieve the string of whatever effect we selected so that we can use switch case, and under switch case is all the different effects. And the first effect we have is reverse, and it takes the handles.desired, which stores the audio file, and it flips the array so that it can be played backwards. And next we have voice removal, and essentially what we're doing here is indexing within the array to remove the voice out of the audio file. And we also have effects like tone low, tone high, which just plays the high notes of the audio file and low notes of the audio file. And then we also have delay, which delays the play of the audio file. And then next, we also have another effect is the speed, changing the speed of the audio file, which is also a pop-up menu. And again, we're storing the effect as a string and then using switch case. And here, for changing the speed, whether we're slowing it down or speeding it up, if we're slowing down the speed of the audio file, we're taking the frequency rate and we're dividing it by the amount of time we want to slow the audio file down. And if we want to speed it up, we're taking the frequency rate and we're multiplying it by the rate which we want to speed the audio file up. And lastly is the chopping. And so the user is able to input a start time and an end time of which they want to chop the audio file. And so the start time, we're retrieving from the edit text, and we have to convert the string from a number to a string, and then we multiply the frequency rate by whatever number was input. And that's the same thing as the end time. And for the chop push button, we're indexing the handles.desire, which is the array that stores the audio file, and we're indexing from the start time to the end time. And that's pretty much it. So this is an example of some of the different effects that we can implement on the audio file. So we're going to reverse. And then we'll do tone low, which just pretty much plays the low notes in the song. And then we can also do speed up. And then lastly, we can also chop the audio file.
And all the clubs you get in using my name. You think you broke my heart, oh girl, for goodness sake.
And that's it.
I'm Elena Latoy, and for the project I did the basic tone generator or synthesizer. And for this part of the project, the GUI is actually in the form of piano, each designed with a specific note. Each of these notes plays a different frequency defined by the mathematical equation y equals a wave type, which depends on what is selected between sine, cosecant, triangle, square, or tangent. The equation that goes into this function is 2 times pi times time times frequency and then times current pitch. The frequencies each vary depending on which note is playing. For instance, A0 has the frequency, which is demonstrated right here, as 27.5. And then B1 plays the highest note with a frequency of 61.735. In total, the program has a total of 14 separate codes, one for each note, which is defined by a series of if-else statements, which is showed here. And those play a certain note depending on the octave selected and the type of sound waves selected. Under each if statement, we first define time by doing linspace 0, 4, and then 44,100. Next, we define the equation by first typing in the desired wave type, which is different for each if-else statement, followed by the equation mentioned earlier. There are a total of 6 different if and if-else statements. The first to show an error that pops up just in case nothing was selected, and that would say choose a wave and octave type. The next 5 is for each different type of wave that can be selected from the pop-up menu for a wave type. The last component under each statement is the audio player function that plays the equation with the frequency of 44,100 samples per second. That was done. For selecting the octave, we use a similar system as the wave selection, using a switch case function that when a current string is selected, the value for current pitch will equal a number associated with that pitch. That will then be substituted in the given equation in the if-else statement for that note. If the person operating this synthesizer did not select any of those choices in the pop-up menu, then the program would generate an error statement that says, please select a wave type in an octave. And this equation right here, handles.current_pitch, is what is also included in the if-else statement. So here's how the synthesizer works. Okay, so we have various octave selections. I'm just going to select 2-3, and then we choose our wave type, which we can choose sine, cosecant, tangent, triangle, or square. For the first one, I'll just demonstrate sine, and then we go. And then we also have the A sharp, B flat. Here we put in the time that we want the recording to be, and then we press record. Now it is recording for 5 seconds. And then now it is recording for 5 seconds. And then do you think that was loud enough?